to those who aren't with us today on Friday the 8th, is today the 8th?
Yep.
Okay. January 8th, 2016. We're finishing up our Mod 6 and we are studying Newton's law, second law, as it applies to two objects at one time. So you have to draw for yourself two objects connected by a string that's being pulled by another string, and we will put in some data now on our drawings. The first object that you drew is 3.5 kilograms. And the second is 4.5 kilograms, so indicate whatever object you drew with those masses. And they're being pulled with a force, and that force is 3.2 newtons. We're going to ignore friction. Not in every problem, but in most. It's not hard to include friction, but ignoring friction for the first one at least.
My ducks look ugly. Little sloths.
Mine look huge.
I want you then to find acceleration and tension.
Unless you can go
So the
line.
tension exists between the two toys right there. So I put in a T for tension there. All right, let's look at how we will do this. We're going to do this in two parts. Remember how the old problem's horizontal, vertical? It's not horizontal, vertical, but it's definitely a two-part problem. So whenever you see me draw the line, you know we're going to do it in two parts. All right, is everyone up with me so I can start? Video land, you have yours drawn and ready?
Draw it, Video Land. Okay, Hunter.
Ignore friction, write down the question, find A, acceleration, and T for tension. All right, so we're going to do the first part by just looking at all the forces on just the one toy. So I'm going to start with the toy on the left, and I know the sum of the forces equals MA will come out to play. So what are the forces on this duck? Well, you might say the weight down, but that's counterbalanced exactly by force normal up. So since the duck is not moving, it's not floating, it's not levitating, it's not crashing to the floor, I'm going to ignore those vertical forces. They have a net effect of 0. So what forces remain in the horizontal direction that you can see? What do you see, Emily? Number 2.
Force of the string.
Right, and what do we call that force?
Tension.
All right, tension. And if we call this side positive and this side negative, you may define it in your own way. But since I picked that because it's to the right, it's often called positive, and it's actually the direction that the object is supposed to be going in. So with that intelligent choice of plus and minus, is tension going to be plus or minus, Emily, too? Why is that?
Wait, so it's because
It's a tricky question.
it's positive.
It's positive, why?
Because it's pulling it out.
All right, tension is always, it's the easy way to get it correct is to think of it this way. She's right, but tension is always away from the object that it's pulling. So this part, in this picture, in this frame, do you see tension is going to be away from this object? So in this box, tension is to the right, so I'm going to call it positive. Since we're ignoring friction, there are no other forces. So that's not too complex. The sum of the forces equals MA. So I'm going to put in some numbers now. I don't know T, mass I do know, and acceleration I don't know. So that's all I can bleed out of this turnip. Can't get much out of it. But it will be important to us when we finish the second side. Alright, as you probably see where I'm going, I'm going to do the same sort of thing over here with this object. Right here. So that's going to be the second side. And I'm going to start with the sum of the forces equals MA. Seeing how I set it up here, see if you can work ahead of me for a minute and find some forces working on this toy, the one on the right. All right, let's see how you're doing there. When I did that one, I saw that there was a 3.2 Newton force going that way on this object, so it's in the positive direction. I'll call it general, the force of the pool. We'll put in the number 3.2 in a minute. But then there's a tension also on this side. The string is also connected to that second object on the right. But again, tension is always away from the object. So it might be confusing to you, but tension on this object is negative, while tension on that object is positive. So if you didn't get that, I understand, having not seen that before. When I came up with all the forces on the second object, that was all there was. Mass and acceleration. So now we put in the numbers that we know, and we know 3.2 is the force of the pool, minus t, we don't know. When we do get t, it's going to be the same on both sides.
Yeah,
So even though t has different signs, its quantity is going to be the same.
The quantity is the
Forgot
same.
to start the timer.
Yeah, that's it.
How long have
Write
we
that
gone,
down.
you think, maybe?
Long.
Not too long. Probably about
Maybe
like 3.5 minutes, 4, 5, 6 minutes.
Say 5 minutes.
Okay.
So I'll set
That's a,
another 5.
that's a good
4,
guess.
5.
That's a
I'll set up
solid
for
guess.
7 more. Okay. All right, so now we have mass given as 4.5 and acceleration. So, oh, mathematicians, what do you think you could, there's several things you can do from this point. Zach, what's one thing you could do to solve this now that we have this and this?
You could add t to both sides or subtract 3.2.
Can you just substitute t?
Oh yeah, you can substitute t too.
All right, substitution. We're over here, we know that t is 3.5 times a. Don't forget to take the a with you. We're going to substitute that in over here. And you could also set that up for elimination by rearranging the terms. And but this is probably the quickest way, so we'll go with it. 3.2 minus, when I get to t, I'm going to put in instead, by substitution, 3.5a. And that equals 4.5a. So now we can combine the a terms by moving the 3.5a over to the other side by addition. 3.5a and 4.5a comes up to be 8a. So I'm going to work over here. So on the left I have a 3.2 and an 8a. Divide. And 8 goes into the 3.2 40 times. I'll put 40 point times so I can count that 0. It's meters. Is that right? What's 3.2?
Isn't it point
Point
four?
four. Point 4. I'm sorry. Point 4.
Like 40?
Right.
No.
Meters per second squared. That would be quite an acceleration. 40 meters per second. Meow. Faster than the speed of light.
Jackson, feet on the road.
All right. 0.4 meters per second squared. Are we done?
No.
Yeah.
You have to go back and
All right.
substitute.
All right, we have to find tension. We found acceleration. It doesn't matter which one you find first, but this one, our mathematical nose just led us to this point. So now we go back over to the right where we know that tension is 3.5 times acceleration. So tension is 3.5 times 0.4. So with 2 sig figs, that came out to be 1.4
Yep.
newtons. Tension is in newtons in this problem. Pounds sometimes, but not in this problem. So the final answers are this and this. I don't really think you'll benefit by watching me do more of these. They're pretty much identical to this. So once in a while, I'll give you different things and ask for different things, but it's going to follow this pattern, and I think you can work through it. So let's switch over to our books again and find these problems to practice. I have 4 of them, and I think we'll call it a day. If we finish early, I'll start our review. So,
Ooh,
Oh, I'll take this.
superb. So we have a commercial break.
now let me give them the work first. Page 205 is an
205.
OYO.
Oh, yo.
6
Let's get this.
point 10. There's only one OYO there.
Oh, yo.
Page
Oh, y'all. Seeing that? Hey.
13, number 10 is another one. This one is sailboats. So I thought it was creative. Then back in the back, I found two more. Page 570, number 9.
Yes, it is 7th to
and
the 8th.
Number 10.
8th. Wow, 1 month to the Super Bowl.
All right. This Mighty Four should
month into the
solidify this type of
17.
problem in your minds. All right. Let me show
Yeah,
you.
true.
If we still have a minute,
Wait, Miss
we do.
Powell.
Let me show them the problems in the book.
Page
Alright, we'll show you
205.
problem
Oh,
books,
yeah.
guys.
Look at that. Me and the yo-yos. Me and the yo-yos. Think
Whose book? Here, this is yours, right?
Yep.
Okay.
look beautiful.
Page what?
205. Oh, yo,
Would
6
you shine a light on this? We'll show you those problems in case your book isn't handy. Show them this one. Here's the first one.
Here's the first one. Hunter and Brandon. Alright. Alright, so you might want to pause that. Pause it right there. Pause it.
Got it?
There you go. Pause it. Do it and read it. Thank you.
Already done it.
Alright, so if I pause it, yep.
Yeah, but just one job.
216.
One job.
Now it's going to be number 10, just this one.
Alright.
Another book problem.
How did I randomly turn this?
Alright, so look at that. Look at that.
Number 10 down here.
Yeah, I got it. 10. Pause that and read it and do it. Thank you. Thank you. Thank you. Pause it.
570.
If you didn't pause it, I'm gonna come to this TV screen and I'm gonna attack you. Okay.
All right, it's going to be this one. Ooh.
Ooh.
And this one.
Alright.
Zach, the last one is like your scenario that you drew.
Alright, so pause that. And then look at this one. And pause this one. Thank you.
This is such a complicated
did?
drawing.
Sure, let me see.
Alright, we're going on commercial break. We'll be right back after a word from the local station.
You're